Hey Dr. Co, let's talk about a gold-plated jacuzzi. So we have a jacuzzi. Its water level is 1 meter above the bottom. The water from the jacuzzi is pumped to a holding tank. In the holding tank, that water level is 3 meters deep. Now, the water from the holding tank is released down into the jacuzzi, and that distance is 7 meters. And we can find the distance to the top from the very top of the water in the jacuzzi to the top of the holding tank water level is 9 meters. So, going from here, we have to figure out our systems. We'll call the water traveling down to the jacuzzi from the holding tank system A, and the water getting pumped to the top system B. So let's talk about system A first. We'll call the position at the top from the very bottom of the from the very top of the holding tank water level position 1, and we'll call the very bottom position 2. So the water travels down. The pressure at the top would be P1, that would be equal to 0 because it's exposed to the atmosphere. The velocity at the top would also be 0, basically 0, and then the velocity at the position at the top would also be 0. The pressure at the bottom would equal rho g1 because it's 1 meter below the surface. The velocity at the bottom, we're actually not sure what that would be, so we'll be solving for that. And then the position at the bottom would be negative 10 meters because it traveled 10 meters down. Now we can set up the equation. It'd be P2 minus P1 over rho plus G Z2 minus Z1 plus V2 squared minus V1 squared over 2. That's equal to 0. So from here we plug in what we have. We'll have rho G1 over rho, the rho's will cancel, plus G, it'll be negative 10 minus 0, plus V2 squared over 2, because V1 is equal to 0. After we do some math here, we get that V2 squared over 2 is equal to 9G, and then finally we get V2 is equal to square root of 18G. Now we can use this with the cross-sectional area of the pipe to find the flow rate. That's A2 cross-sectional area times V2. A2, a 10-inch diameter pipe, that is equal to 0.0507 meter squared area for the cross-sectional area, and then that would be times square root of 18 9.8 for G, and that would be our flow rate. Now we'll move on to system B to find out the non-flow work over mass associated with the pump. So for this, we'll set up another thing. We're going to make the very bottom position 3, and then where it pumps to position 4. So position 3, the pressure at 3 is equal to rho G1 because it's 1 meter below the surface. Then then we have Z3, and that would be negative 10 because it's negative 10 meters below, or it's 10 meters below the top. And then for P4, that's equal to 0 because it's exposed to the air at the very top, and Z4, that's also equal to 0. So now, and we don't consider the velocity because there's no change in kinetic energy here. We will then plug this in to P. It'll be P4 minus P3 over rho plus G, Z4 minus Z3, and that would be equal to the non-flow work over the mass. After we plug all this in, we'll get negative rho G1 over rho. We can cancel the rho's out, plus G, and it'll be 0 minus negative 10 equal to the non-flow work over the mass. After we simplify, we find that 9G is equal to the non-flow work over the mass. Finally, we can plug this into to find the power. It'll be the density times the flow, this Q right here, times the non-flow work over the mass. That'll give us 1,000. That's kilograms over meters cubed, and that'll be 0.0507 for the cross-sectional area. Then we have square root of 18 times 9.8, and then we finally have 9 times 9.8 for the non-flow work over mass. That gives us a power equal to about 59,392 kilowatts. Now that we have the power that's needed to pump the water from the bottom to the top to keep the jacuzzi at a water level of 1 meter, we're wondering if we need a chiller to cool down the system because of the pump. And the answer is that we do need a chiller. We need one because if there's power going into the pump, we need something to counteract the heating that's associated with the pump bringing the water back to the top. If we didn't have the chiller, then the system would overheat, and it would not be good for our energy-conscious king. Thanks, Dr. Co.